I am following American standard, then the opposite side doesn't know what I am talking. So please note, compliance to Indian standard is very much essential, very much necessary, and in case of violation, the owners of the enterprise, the general manager of the hospital, they can be put in jail. There is a provision in the Electricity Act. The only point is when this provision is applied. Now, how does the standard explains? The medical establishments there are two safety measures required. All the locations in the hospital should comply National Electrical Code 2023 Part 1 all sections, and medical locations need additional safety measure, which is explained in the Part 3 Section 9. Here we are talking about the design, selection, erection, initial and periodic verification of the installation. Please note, when I say installation, it is not the biomedical equipment. It is not an equipment which you are using. It is about the selection of the conductors, selection of protective device, how you are installing these the wirings, how you are routing the wires, how you are fixing the wires, what is the rating of the wire, what is the rating of the protective device, and so on. So design, selection and erection, initial and periodic verification. Now, the equipment which you are using, biomedical equipment, they are in compliance with the IS 13450, or the equivalent is IEC 60601. This is the standard. With respect to standard, these are very well documented. Please note that the information in these standards, don't hesitate to follow. The information in these standards are very much reliable. They have been made with the experience, global experience for decades, maybe 40, 50 years research has gone into it, and very well these are defined. Example, applied part. Applied part are the parts of biomedical equipment which is touching the body of a patient. There are three types of applied part. As you can see, applied part B, BF, and CF. These are finally the parts of the biomedical equipment which is touching the patient. Of course, the biomedical equipment are classified into class 1, class 2, class 3, different classifications are there. But what is important for safety is all these equipment are capable of working or creating a safe environment during the first fault. Now, you are installing the equipment in medical location. From here, this is very important. Medical locations are classified into group 0, group 1, and group 2. Whereas this group 1 and group 2 are medical locations, which is very important activities are going on. Group 0, medical location where no applied parts are intended to be used. Group 1, medical location where applied parts are intended to be used externally or invasively to any part of the body. Whereas group 2 is a medical location where applied parts are intended to be used in applications such as intracardiac procedure, operating theaters, and vital treatment. Failure of the supply is a hazard for the patient in group 2 location. In group 1 location, even if there is a disconnection of the supply, you don't need to be worried. Now, this classification, the standards and the regulation, you can find this kind of a table with, of course, with explanations like what kind of activities are going on in each of these locations. Example, the urology room, radiological diagnostic, hydrotherapy room, physiotherapy room, and these classification you can see on the right side. The group 0, group 1, group 2. These are classified. Let me show you a little bit information from the Indian standard IS 17512. So this is the Indian standard IS 17512. Let me make it wider. Just a moment. Yeah, the Indian standard IS 17512, which is please note that Code of Practice of Electrical, 17512, requirement of electrical installation in medical location. So this standard explains the requirements in medical locations. Now, if you go here, let me read a little bit for your information. Supply, type of earthing system. TNC system is not allowed. That means you can go for the other type of device, other type of systems. For IT, I'm talking about clause 6.1.3.11, disconnection of supply. Disconnection of supply means during a fault, the electricity has to be disconnected within certain time. In medical location, group 1 and group 2, the following shall apply. In TN, TN and TT system, conventional touch voltage not exceeding 25 volt. That means during a fault, the touch voltage has to be limited to less than 25 volt. The disconnection time has to be limited lesser than what you are seeing in the table, maybe 0.4 seconds, 0.2 seconds, and so on. So then you need a medical IT system. You need a supplementary equipotential bonding. So all these measures are very much essential. Example, one of the example which is blatant violation in India. Example, you can see I just highlight. Electrical device, for example, socket outlets and switches shall be installed at a distance at least 0.2 meter horizontally, center to center, from any medical gas outlet so as to minimize the risk of ignition of flammable gases. So this is a very, very essential measure. I have a picture. I will show you later what happens. So basically, the first subject is you must ensure that the medical locations are classified. You can do it very easily. You download the standard, you read it, you make a table and understand what kind of rooms are group 1, what kind of rooms are group 2. If you have a conflict, then you should classify all the groups into group 2. There are pictures in the NEC 2011, 1985, which explains how to make equipotential bonding in a hospital. Please note that in one hospital, even a big multi-speciality, super speciality hospital, you need one earth electrode, only one, not 200, not 100, not 50, only one. So if you make it more, then you are actually in trouble. So these pictures are there. Pictures are there how to make electrical installation, how to make bonding in the operation theater group 2 location. These are very much there. Disconnection times are defined in National Electrical Code. We have very clearly mentioned the disconnection time, for example, at the main distribution circuits, final distribution circuits. So the disconnection times, example, TN system less than or equal to 5 seconds, the TT system 0.2 seconds. The most important point is the disconnection time is specified. Now you must ensure that your protective device is able to trip within this particular time. And if the device is not tripping, hazard happens. Most of the electrical fire accidents, if we study in detail, you can understand that the protective devices are not tripping. If the protective devices are tripping, then a lot of accidents can be reduced. Similarly, the touch voltage in each of the group is very much specified. Fault loop impedance, one important subject which is catching up very fast in the country. It is not a new subject. It is existing since probably 1966, but in the new standards and regulation, this subject has been explained very well. Depending upon the type of the MCB, rating of the MCB, you have to keep the impedance of the circuit to certain level. In the sense, when you have a DG, when you have a transformer, when your equipment is running from a UPS, the minimum requirement of the impedance you have to satisfy. This subject has to be calculated during design. This has to be tested during erection commissioning. This has to be checked periodically to ensure safe disconnection of supply. And this is one of the first electrical safety measure when you do a safety audit. Keep this in mind. The subject is earth fault loop impedance. Group 2 medical location need additional safety measures such as the medical IT system. Here the concept is, in group 2 medical location, the life of the patient is supported by electricity, and in case of disconnection of supply during a fault, the patient's life is endangered. In order to avoid that, there is an additional supply system, as you can see here, medical IT system. Please note, it is not a UPS with an isolation transformer. It is not an isolation transformer alone of maybe 25, 30 kiloampere. No, medical IT system has got certain specific requirements. Medical IT system are a special panel board with isolation transformer, with insulation monitoring device, with the leakage current monitoring devices and multiple safety measures specifically for certain equipment which is used in the operation theater, for example. Now, imagine in the pendant you have 16 plus 16, maybe about 20, 30 plug points. Once maybe 10 are already used, and if somebody put a plug point on the plug point a faulty equipment, and if the circuit trips, then you are in danger. If you use a medical IT system, even if you put a faulty device into the socket, the system don't trip, it will give you an alarm. So once when you get an alarm, you can either disconnect the equipment, or you don't need to worry if you don't have an equipment. You can continue the operation, you can finish it. So this is very much essential. Also, this isolation ensures that some of the equipment, the EMI, electromagnetic requirements are met. Chance of shock is very much reduced by using medical IT system, and this is actually a mandatory requirement. This is a must in group 2 location. So the medical IT system consists of example something like this. It is like a panel what you can see in the picture. It consists of a medical isolation transformer as per the standard, which is put on the bracket, medical insulation monitoring device, medical fault locator. Please note that everywhere medical is added. IT system is different from medical IT system, or medical IT system is different from a non-medical IT system. Medical isolation transformers are very special. It is not a normal isolation transformer. Medical insulation monitors are very special. It is not a normal insulation monitor. Medical fault locators are different than a normal fault locator. Earth line monitors, monitoring and communication panel, alarm transfer unit, all these things together as a separate panel, and the power supply to some of the plug sockets or sockets in the operation theater and the ICUs are to be used through this specific panel. Maximum capacity of the panel is 10 kVA. Higher capacity equipment are not supposed to be connected to this particular panel. The panel has to be within 25 meters of its usage, means you have to keep it closer to the location where you are going to use electricity. The leakage current has to be kept minimum. So many additional safety measures are included in medical IT system. So medical IT system is a mandatory requirement. I was just reading from the standard. Clause number 7.2.2.1, explosion risk. Electrical device, for example, socket outlets and switches, shall be installed at a distance at least 0.2 meter horizontally from any medical gas outlet so as to minimize the risk of ignition of flammable gas. Now on the left side, you can see a picture. There is a medical gas supply as well as the electrical supply in the same arrangement, and you can see the distance. This kind of installation is very common in India. Probably 50-60% of the hospitals you can find this kind of installation. The requirement is medical gas should be at least 200 millimeters away from electrical sockets. It is, you are not supposed to make it in this way. In multiple cases, once when you plug in or once when you take out the equipment, the fire happens and you have oxygen nearby, and this is creating disaster. So basically, a lot of accidents can be avoided or reduced by implementing the actual safety measures, creating awareness. People should educate, people should understand the safety requirement and implement it. As a result, high level of safety can be achieved. Then electrical safety audits. This is another mess, I would say. Sorry to use the word mess because it's a mess. The standards very clearly made what to do as verification. Verification consists of inspection and testing. Let me use generally the word is audit. It consists of inspection and testing. Now, initial verification and periodic verification. Initial verification means before you use the building, before you use the transformer, before you use the panel board, before you use the wires, switches, sockets, you are supposed to make a verification consisting of inspection and testing. The list of items to be inspected are very much listed in the standard. It is not like one subject, a sequence of inspection is required. The format for recording these inspection are included in the standard. However, NFE, we have published a guide for electrical safety audits in hospital, where we simplified the subject and put formats so that even a non-engineer can read and understand and start inspection in a hospital. So it is not one subject, it's a sequence of subjects to be inspected. After inspection, there is a sequence of subject to be tested, starting with continuity of conductors means find out any loose contacts are there, the resistance of the wires after installation are intact. The second one, insulation resistance, test for all the insulation resistance of the entire installation, including the panel boards, wires, and so on. Then the other safety measures such as SELV, PELV, and electrical separation, of course, these are very much applied in medical locations. Floor and wall resistance impedance, polarity test, effectiveness of automatic disconnection, and the last one is voltage drop, and one more, which is PAT, portable appliance test. Please note, the biomedical equipment frequently or before using, and once when you start using, you are supposed to make a portable appliance test. Appliance test means just to confirm that the biomedical equipment is in good condition. Here, not only biomedical equipment, every equipment you are using in the hospital, electrical equipment, you are supposed to do a test. Example, if you are doing a PAT test in an air conditioner, even though the air conditioner is running 24 hours, if you are making a PAT test probably once in a year, you can very well find out the leakages in the air conditioner and you can rectify it so that the chance of fire from air conditioners can be avoided. Annually in India, almost 350 plus accidents are happening due to fire from air conditioner alone. And in hospital, this is especially in OTs and ICUs, this is a real hazard. Fire from air conditioners, in multiple occasions this has been reported. If you are doing a pad test once in a while, maybe once in 6 months, it's a small instrument, maybe costing 30,000-40,000 rupees. The hospitals can buy it, keep it with your technician, and he can make the test whenever the area is free. You can very well easily find out the fault of the equipment. So like this, there is a sequence of tests required in your electrical installation. I'm talking not about the biomedical equipment. This is about the electrical installation, means the electrical equipment other than the biomedical equipment. Of course, biomedical equipment also need a portable appliance or a kind of portable appliance test. So these tests are for the normal electrical installation. Then we go to group 1, group 2 location, means the critical location where operations or patients are there. These locations, we need additional testing. Additional testing including insulation monitoring device, whether these devices are reliably working, whether the insulation itself is in good condition. You have a DG, whether the DG is able to start, cold start, whether it is able to take up the load, whether the UPS is having sufficient backup, whether it is able to support the 100% load. All these are part of periodic verification. But what we do is thermography. Unfortunately, this is not a part of, whenever I say thermography is not a recognized electrical safety measure, of course, a lot of people object it, because a good electrical installation is not supposed to have hotspots. You make a perfect electrical installation so that there is no loose contact and there is no hotspot. If you have a building, if you have a hospital, and if there is hotspots inside your panel board, it means your installation is not in compliance with the standard. So you are in an extremely dangerous situation. So this inspection and testing, which I have shown in the previous slides, if you have a hospital where the inspection and testing is 100% made and all the systems are pakka, then you can make thermography as an additional measure. Don't try to relay only thermography and think that everything is safe. This is wrong. Unfortunately, sometimes our authorities also make this mistake. This was from the earlier NABH requirement, which says the help of new technology like thermal imaging equipment help detect loose connections in the system. This is blatant violation of the rules and regulation. So, and this is unnecessarily making unsafe situations. Sorry to say this. Thermography, as I said, it is not recognized. It is not a legal requirement, but all the other testings are legal. Periodic verification of medical equipment. The IEC standard, there is an IS standard 62353. It explains that every biomedical equipment has to be tested. That means you have to have a meter like this. You have to test the biomedical equipment once in a while. Then only the fire and accidents from these equipment can be reduced. You can also find the information in the manuals of most of the manufacturers. Example, this is a GE, one of the equipment you can see here. I just highlighted some of the subjects. Maximum line resistance. Okay, this equipment 70 kVA and the line resistances are mentioned 0.15 ohm. That same line resistance has been, the new modern word is line impedance. Before installing this X-ray machine, the biomedical engineer or the biomedical equipment supplier is supposed to check the line resistance and ensure that the line resistance is lesser than 0.5 ohm. If the line resistance is more, of course, this equipment will create danger. Example, Siemens. The catalog says, the manual says it is suitable for a TNS system, three-phase N and PE system, and the line impedances are very much mentioned. If you are installing the same machine in a location without complying the highlighted parts like TNS or the line impedance, you will be in trouble. The equipment is going to create much more trouble and you will create unsafe situation. Now, when it comes to India, biomedical equipment manufacturers create their own manuals, something like this. This is from one of the biomedical equipment. Example, earth megar value should be less than 1 ohm. So by measuring, we are checking the insulation resistance. So insulation resistance should be more than 1 mega ohm, whereas here it is written less than 1 ohm. And a lot of additional equipment or a lot of additional requirements are being created by the biomedical equipment companies, which is creating a total hazard. I would say if there is an accident from a biomedical equipment, such as a fire or a shock to a patient, the responsibility directly lies on the biomedical equipment supplier because they are violating the electrical safety requirements. Something like this. Non-standard installation. Every biomedical equipment demands so many earth pits, zero, one less than 1 ohm resistance. This is blatant violation. These are non-standard installation. One of the catalog which I saw recently was so funny. You can see here the equipment, biomedical equipment manufacturer. He says he needs 6 numbers of chemical earth electrode. Then he is also saying, if you are putting water, the water trench provided for earthing, neutral earthing water provision should be separate. That means if you are putting water on the earth electrode to reduce the resistance, you have to use different water for different earth electrodes. Please note, these are non-standard methods and these are the reasons for accident. Now, what kind of recommendations? In an existing hospital, the situation can be improved. First, the management discuss with all the stakeholders and they have to classify the medical locations, electrical classification of medical location into group 1 and group 2 location. You make it as a table, inform everybody saying that, look, this is electrically group 1, group 2 location, and group 1 location require X additional measures, group 2 location require Y additional measures. In case of an accident in a group 1 location, what kind of measure you can handle? In case of a group 2 location, what kind of measures you should do? This can be educated. This is the first step. Of course, NFE can help you in making this. Ensure all safety measures in group 1 and group 2 medical locations are fulfilled. Example, supplementary bonding, medical lighting, clearances, routing, termination. These are actually simple methods. Sometimes not very simple. Sometimes you have to spend money, but most of them are simple methods. By training itself, we can improve the system. Make electrical safety audit as per National Electrical Code of India. Formats we have in NFE, we have created a hospital safety guide, and this guide is really helpful. You can go through the guide and you can make an electrical safety audit in a hospital. NFE also in last 2 years, we have created certified engineers, NFE certified fault loop impedance testing engineer, NFE certified ESPCS, electrical safety professional certified engineers. So you can make use of FLIT and ESPCS. These are engineers who undergo the training by NFE. They have to write an examination. They have the certificates, and they are actually better than the normal electrical safety auditor because most of them they know the subject. If you have an auditor already, the management of the hospital, you can tell the auditor that next time before making an audit in a hospital, you go and get the certificate from NFE. So they have to participate in the training. They have to write an examination. They have to, as a result, their skills are improved so that we can make safer electrical installation. Why I'm stressing on this in this subject is most of the time, unsafe situations are created because of unskilled or reduced knowledge of the engineer. Then once when you made the audit and once when you identified the mistakes, prioritize the mistakes based on the hazard involved and rectify the same one by one. Because if you start rectifying everything at a stretch, probably this is not possible. Non-standard demands. Get the medical non-standard demands means once when you start rectifying the demand, the medical equipment vendor will jump out and he will say, no, I need this, I need this. Bring them into the table. NFE can train them with the standard. We have the resources, we have trained people, we can get international people as well. We can explain to these biomedical equipment manufacturers how they should install and how they should maintain the electrical installation or biomedical equipment in your hospital. So please make use of these measures, because if you make a very good electrical installation and if you put an unsafe electrical equipment, again you are in trouble. Ensure that transfer potentials from discoms are within the range. Ensure the installation is in compliance with the NEC of India. Similarly, for a new hospital, you have to start it from the planning stage onwards. During planning, the stakeholders, including the designer, including the owner, including the doctor, including the medical staff, they have to discuss each other and they have to find out the risky areas, which is identified and put in the standard. Example, the duration of discontinuity. Okay, if there is a failure of supply, how much time you can tolerate? Whether discontinuity is accessible or is it okay or not? Then what kind of grouping of the locations are required? So basically, this has to be decided by the management and the experts and the doctors together. Then once when you design the electrical installation, means an electrical the consultant is designing, he has to 100% comply the regulation and standard. All the list of items are given here, starting with the type of supply, tolerance, nature of demand, and so on. I don't want to read it. Select the electrical equipment which is in compliance with the IS standards, and in the absence of IS standard, IEC standards can be used. Erection and installation, here workmanship, competent person, proper material. NFE has published an installation guide which includes some tips of how to erect the electrical installation. It explains what is the need of segregating distance between wires, how the wires has to be routed, how glanding has to be carried out, how termination has to be carried out. So you can make use of NFE installation guide to get some tips. Initial verification, I would say very important. Please note that the initial verification has to be carried out by a third party, means the consultant as well as the contractor should not be involved in verification. This has to be by a third party, because then only the mistakes can be identified. termination problems can be identified, cable routing problems can be identified, glanding problems can be identified, and you can rectify everything. Verification of electrical installation, including medical electrical and medical electrical system. Now you have the formats, you fill up the format, rectify the defects before starting the usage of electrical installation. The last one is periodic verification. Periodic verification, 1 to 3 years, you can make it. The list of examples of requirement of this is for the consultant. Normally, the consultants design electrical, mostly they only consider the voltage drop. Based on the voltage drop, the wires are selected. It is not only the voltage drop, there are multiple parameters which need to be considered while designing the electrical cables. Similarly, multiple parameters are there to be considered when selecting a protective device. You must select or you must consider all these points in the design. Example, if you are buying the switch gear and control gear assemblies, means the electrical panels, legally you are supposed to use electrical panels which is in compliance to ISIC 61439. Now if you look into this particular standard, there is an annex, and the annexer C explains what kind of information are required to make a panel board. Similarly, for the bus bar trunking system, Annexer C of the standard explains what kind of requirements are there to make a good quality bus bar trunking system. So, in a nutshell, please note that there are so many challenges. Each of the point which I have mentioned during my initial slide is very much essential. As you can see here, I am showing it once again. The patients are in unconscious situation. This is a, please don't treat electrical installation in a hospital like electrical system in a normal house or in an industry. Hospital is really critical. The challenges are really, it can create fire, it can kill patients, it can create much more hazardous contamination and so on. So this is the subject which I wanted to explain. Now we started with the subject of fire, but if I start explaining the fire, very simple. If you follow these rules regulation, the fire accidents can be made very minimum. Thank you very much. Over to you, Dominic.
So I would request you to play the video that the link is given to you. Can we play the NFE video, sir?
Yeah, let me check. One
I have
moment.
a problem with audio.
Yeah, one moment,
And it
please.
gives them the role that you're playing in the society.
Yeah. Which video I'm supposed to play? I have the
Corporate
NFE and
video, sir.
corporate video.
Oh, that one. That, yeah.
Yeah, I don't know whether sound is coming or not.
It's not at playing, sir.
Does the sound is okay?
No, it's not playing.
Oh, one moment.
We have shared you the YouTube link also on WhatsApp.
Okay. One moment. I'm just.
So those who want to put up a question to Mr. Gopakumar, please use Q&A box down. We have a menu. So the subject has to be relevant to today's webinar. In the WhatsApp we have given, you can see your screen fully. Yeah? You want me to play and see, sir? This time I'll try to check my luck because this morning we're trying our best to play the video. No, there's no audio. No audio here, Lakshmi. I think we have an issue with the audio output. However, I'm requesting people to put your question and answer for NFE. I urge you to become, because we are putting up a link here. As I said, it is not possible to spread the awareness of electrical safety only through few people, handful people in NFE. I would urge you to become a member. And we are running a NFE CSR mission uh, requesting the corporate to contribute their CSR fund to go to school. Through engineering colleges, we want to go to schools. At least the children of the next generation need to know about electrical safety. And we are running a huge campaign. We are intent to cover 50,000 students in this year. So I urge those who are entitled to, contribute CSR fund through your company. So please get in touch with us. We have the mail ID of our president, and please share your thought. And we would like you to become a member of NFE. And also, if you are a corporate with CSR qualified funding possible, please. We have a lot of information to share with you. You can send a mail, we can share you the purpose of it, how we are going to execute this CSR active mission, I would say CSR mission throughout the country. I'm saying only if you all come together, these kind of accidents that you see in the hospitals, buildings can be avoided. So I would sincerely urge you to become a member and also contribute to your CSR funding. So we'll straight away take the question answers, sir. There are
Am I
20,
audible now?
yeah, 15 questions. Can you take up your question, sir?
Am I audible now?
Yes, sir. Yes, sir.
Okay, thank you. So probably the Q&A, we have some questions. It starts with what is that independent earth electrode? Okay, so please note there is no subject called independent earth electrode. It is a misunderstanding, so please don't follow it. There is a question. Sorry, I don't know. I don't understand EMC. EMC is electromagnetic compatibility. EMI is electromagnetic interference. These are high frequency conducted and radiated electromagnetics, means through air or during operation of an electrical or biomedical equipment, through air or through a copper conductor or a wire. The electro high frequency can be conducted or radiated, which will destroy the work or the normal operation of a nearby equipment. So EMC is basically electromagnetic compatibility. That means once when an equipment operates, the nearby equipment should not be disturbed. The classic example in hospital is this electrocautery machine. Whenever the electrocautery machine works, probably the nearby equipments are in trouble. So the next question, it is fault of display of ventilator only, so no fault in electrical wiring. Yeah, Mr. Upadhyay is saying probably the video, it is fault of the ventilator which was creating fire. It is not like that. The equipment will safely work provided the supply is supporting the equipment properly. With respect to biomedical equipment, as I have shown two examples of two equipment, biomedical or some kind of medical electrical equipment, there is a parameter called, am I audible, sir?
Yeah, go ahead.
Yeah, there is a parameter called the impedance of the circuit, and if the impedance of the circuit is not in line with the minimum impedance requirement of the equipment, of course, the protective devices in the ventilator will not work. The fuse in the ventilator will not blow, resulting in fire. Next question, precautions need to be taken while upgrading, adding new electrical device to existing network. Example, additional AC units will fetch additional load. This is being done on need basis and urgent basis. Such situation lead to safety concerns. So Mr. Naik says, once when you add the load, the additional load without considering the wires and protective devices will create unsafe situation. I'm sorry to say that this idea is wrong. A good electrical installation the wires are selected based on the protective device. That means you can use it for certain load safely. And if you are overloading, the protective device is supposed to trip. So you cannot overload a circuit if it is in a good condition, because the protective device will trip. So once when your protective device trips, then you are in a safe situation. But the question is, if your protective devices are not rated properly for overload, then you are in trouble. So it is not overloading the problem. Overloading is not the problem. Protective device not operating during overload is the problem. So have you removed any questions, Mr. Dominic? So suddenly.
Yeah, no, this is Prabhakaran.
Yeah. Why there is any SOP in any standard for PAT? Which standard is used? Of course, there is a standard, for example, National Electrical Code of India. The PAT is explained. It is very much essential. Mr. Vaidya is asking, is there a way to check?
You have missed an important question. Prabhakaran Jayaraman, the first question is asking on the top.
Okay.
Test on EAS 615 perform.
What type of tests can ESA 615 perform? That is, I think, the equipment which I have shown, the handy instrument for the biomedical equipment. Please put your question properly. I am unable to understand because I have shown a lot of slides. What kind of equipment are you talking is the question. Probably you are talking about, okay, the electrical safety analyzer. You can search in the respective company's website, and so here the catalog of the manufacturer says ESA 615 electrical safety analyzer brings fast and simple automated testing to a portable analyzer for healthcare technology management professionals that perform electrical safety testing on medical equipment both in the field and in facilities. While it is okay, it's very clearly written. Probably if you look into the video, the explanations are there. So ESA 615 tests to ANSI, NFPA 99, IC 62353, then IC 60601, and different standards. ESA 615 is an all-in-one solution with a safety analyzer and the ECG simulator in a single test instrument. Please look into the catalog of this particular supplier. Is there any certification for design consultant? Of course, there is a certification. The ESPCS, Voluntary Scheme Electrical Safety Professional Safety Engineer, ESPCS of NFE can certify electrical consultant. But please note that it's not that easy. The consultant sometimes need to really study a little bit and write an examination, and sometimes the experienced people are a little bit reluctant to do it. But anyway, it's a question of time. We need more clarification to avoid fire incident in critical care units. Okay, clarification. Why fire is happening? Because I'm only talking about the electrical reasons. I'm not talking about the other reasons. Conductors carrying current are supposed to keep the temperature to certain level, let's say 70 degrees or 90 degrees. If the temperature goes beyond certain level for a sustained period, of course, electricity ignites fire. The protective measure to be implemented is not protection from fire. It is protection from thermal effect. That means electricity should not create a thermal effect. Electricity should not create arcing. Electricity should not heat up terminals. It is not one safety measure to be implemented. It's a sequence of multiple safety measures which need to be implemented in a location, which is very much included in the standard. In an existing location, first you have to identify, let's say, for example, the sizing of the conductor, the loose contacts in the terminal, sizing of the protective device, how you are making the bonding, and so on. So you have to make a test and you have to identify these problems and you have to rectify. It is not due to one subject. Example, air conditioner fire. Yes, if you can do the PAT test of the air conditioner, then you can reduce the fire accidents to a very low level.
There's one more question on the top. Urmil Vaidya is asking on the top.
Is there any way to check loose connections in an electrical installation? Yes, Mr. Vaidya, that is the first test in the electrical installation, which is called as continuity resistance test. Continuity resistance means you have to have a micro ohm meter and you have to test the resistance of the wires, including the termination, before you use the electrical wiring. And you have to record it in the prescribed format. That is the first test. So it is not a way to test. It is a mandatory requirement. Before you use electricity, you must check whether the resistance of the connections, including the resistance of the wires, are much lower than the values prescribed. So the next question, once CEAR, Chartered Electric CEA regulation clearly mentioned the frequency of testing of all protective equipment, why it can be enforced to the hospital. Okay, Mr. Kamal Pramanik is asking, the Central Electricity Authority is demanding to make a test once in a while, and why this is not carried out. The main issue is awareness. Rarely people know that CEAR has written insulation resistance test once in 5 years, every 5 years, but it's very, very rarely carried out. Now, the information in the CEAR is very minimum. You have to also do the test as per the standard National Electrical Code. Once when you go into the National Electrical Code, there are multiple subjects to be tested, once in 2 years, sometime once in 3 years, once in 5 years. Thank you for the question. Next question, if supply for medical IT is same for hospital transformer, how can we ensure supply continuity? Of course, at the input of the medical IT can be supplied from UPS. What about earthing in operation theater is the question from Mr. Srikanth. Of course, you have to make an EQ potential bonding, means you must have a common bus bar. All the exposed and extraneous conductive parts of the machines and the equipment must be bonded to a common bus bar in the operation theater. That is earthing, not to separate earth pit. How can gas leak detection play a vital role in early detection? Sorry, this is not an electrical subject. I would like to skip that. From design, what sort of considerations shall be taken while designing cable schedule and relay coordination? Can you please explain, gentlemen, Mr. Baru? I have shown the last slide, which explains the requirements or the subjects to be considered in selecting the device, the protective device, and the cables. Please have a look into this particular slide. We will be distributing the slide. Probably, if you require the slide, you can write to NFE and we will arrange to give it to you. Or you can also look into the video, which will be uploaded in our YouTube channel, so that the information is clear. Lift and elevators in hospital require separate compliance requirement. Many states do not require statutory approvals, and there are no guidelines so far. Say in Telangana, of course, that is. Of course, there is a standard IS 17900. Please try to comply it. Anyway, compliance to, even though there is no statutory approval requirement, compliance to the standard is a mandatory requirement. Can circuit breakers be provided? If yes, what can be MA rating? I don't understand the question, sorry. What safety measures should be taken for UPS room in a hospital? Of course, UPS room, very much important subject. Let me try to share the screen and explain one subject. I think I missed that particular subject. UPS, the challenge is modern UPS uses the incoming neutral as the reference for its PCB. During the changeover from mains to DG or from DG to mains back, during this changeover time, sometime the neutral misses, means the connection to the neutral is missing. That means the reference to the electronics in the UPS is missing. As a result, UPS malfunctions. Same is the situation with some of the biomedical equipment. Because the electronics inside the equipment uses neutral as the reference potential for the electronics, and if the neutral is missing for a short time, the equipment malfunctions. So the solution here is to use a changeover system with all the sources directly connected to neutral. I had the slide. Unfortunately, I think I missed the slide. Probably we will try to address it, or if you can write it to NFE, we will. I can send you these slides, and these are already included in the standard. Of course, the way of changeover has to be a little bit modified. What is the ideal value of earth pit resistance? Oh, very nice question. 100 ohm or 200 ohm or even 300 ohm. All these are ideal values, or 50 ohm or 10 ohm. There is no value required, gentlemen, please note, for a hospital and for biomedical equipment. Is it true that TNS earthing system is good in general for hospital and medical IT system for group 1 and 2? Yes, of course, TNS is best for hospital, and group 2 location you need a medical IT, not for group 1 location. You also should look into the maximum disconnection time of the supply acceptable in a location. What is the presented is not mostly followed hospital earthing. So Mr. Saini says, I have worked for hospital more than 30 years. What is presented is not mostly followed. In hospital, earthing is very important. Can we have separate session on earthing for hospitals from where we get NFE guide on hospitals? Please have a look into our website. These are there. These are included in the website. If you need it, you can put a mail to us. We can send to you. Of course, these are mainly for distribution of our members. The easiest way is you can become a member. Membership fee is very nominal, 1,000 rupees per year. So all these documents will be accessible to you, because we are spending a lot of time and effort to create these documents. So please become member so that all these documents are
what you said
accessible.
is also right, sir. We should have one dedicated webinar on earthing for hospital, because as you see, every hospital got, I think, 16 to 100 earthquake all around the hospital. Places like Bangalore and Mumbai, the space scarcity and the way demanding on earthquake is one very important subject that we need to cover, sir.
Yeah, we can make it, sir. So Mr. Sunil Kumar is asking, as per IEC and NEC 2023, it is specified equipotential bonding with the one earth electrode. Suppose if the sole earth electrode got damaged, and how the reliability will be ensured. Also, if the soil resistance is more, how the touch potential will be limited with one earth electrode. Mr. Sunil Kumar, please note that the IS 732, which is the standard for electrical wiring, including hospital except medical location, there is a clause which says an installation doesn't require its own earth electrode. That means your hospital, even if there is no earth electrode, your system will work, provided you have a very good equipotential bonding system and you have a TNS supply from a transformer. So earth electrode is not the subject. It is a totally, achieving safety is a different subject. What would be the best practice of electrical safety in a already running hospital since ages? I have already shown it in one of the slides, Dr. Anmol. The slide, the explanations are, you have to classify the locations, group 1, group 2 locations, identify the risk in these locations, train the staff, inform the staff that, okay, these are the electrical risky subjects which is there in these areas, and how to handle those risky subjects. Probably we can also have a different session on this particular subject. Then you try to make an audit with a knowledgeable person, probably an NFE certified person. Then you start rectifying the mistakes. As somebody was telling, most of the hospitals don't follow whatever I explained. Yes, of course, in my 20 years experience plus multiple hospital visits, the compliance, if I put marks 1 to 100, I would say maybe I give 5% or 5 marks or 10 marks out of 100. That is the situation. Then I think, Mr. Dominic, the next one is regarding fire extinguishing system. That is not the subject of today. You can remove it. In government hospital, medical equipment are procured after handing over hospital. How to handle this challenge? In government hospital, medical equipments are procured after the handing over of the hospital. Oh, sorry, we have explained what is required in a location. These are procedural systems. You have to discuss with your management and make procedures to ensure the process is smooth. What are the safety measures to take MRI area? Of course, MRI area is an area where the electromagnetics are quite high. You need not only the electrical safety measure, you need to have shielding measures as well. So additional shielding measures are required. Special shielding walls are also required. After completing course from NFE, can an individual work as a consultant for hospital electrical setup? Of course, yes. We are not restricting that you can work only in this area. Or it is up to the user. The only advantage you as an NFE certified person is the market knows that you are a qualified person. You are a person who can handle the subject. So you have learned the subject and you can professionally handle it. So it is up to you to decide where to work. Can we provide fire sprinklers inside the ICU? Probably, Mr. Dominic.
We suggest now use gaseous system or the water mist. There's a separate subject we'll be covering from the Council of Fire and Life Safety. We'll be covering that subject later.
Yeah, as per IS or IEC standard, whether any specified value for the resistance of terminal contact microohms. Actually, terminal contact need not be measured because the terminal joints, including the wires, need to be measured. Let's say a piece of wire, including 2 joints, has to achieve, let's say, 20 milliohm. So significantly, the resistance of the wire is going to contribute. The resistance of the terminal may be in micro ohms, much lower. So including the joints, the wire integrity has to be tested. How to maintain supply disconnection in critical area 0.2 second? Well, very simple. First of all, you have to have a properly rated protective device, and the impedance of the circuit has to be in line with the requirement so that enough current flows during a short circuit and the device trips. How to identify a medical IT from normal IT? Ms. Indira, it's very difficult because you have to get in touch with a company who is doing really medical IT, and you have to. But for sure, NFE can help you. Normal IT is example the UPS manufacturers claiming that I have IT and supply UPS with an isolation transformer at the secondary. This is number one. Number two, isolation transformers and the manufacturer says I need a separate earth pit. This is not medical IT. Sometimes only the isolation transformer with an insulation monitor is given. So the equipment marking, from the equipment marking, you can verify. Probably there is a comparison. We will make a comparison also. We will try to publish it so that it is easy for the users to understand. How to access the checklist prepared by NFE? Mr. Arun, we can send to you. As I said, this is made for the NFE members, but since the subject is very critical, We have no problem in circulating the document. You can download it from the website or you can write to us. We will send you the document. But as I said, not all documents are free for everyone. The documents are mainly for our members. Bed head manual manufacturers are not following 200 mm gap between gas outlet and electrical socket. What to do in this case? Very simple. You stop buying from this manufacturer and go to a manufacturer who is complying with the requirement. I hope, Mr. Dominic, this is very simple. If you know that a manufacturer is not complying to the standard, see, very simple. Simply stop it and ask him to take back all the equipments which he already supplied and go to a supplier who is supplying equipment in compliance to the standard. What are the basic checks to be done for each medical equipment installation? So this is actually, Ms. Indira, this is very much included in our guide. Probably please write to us. We will send you a guide. You can go through it. Ms. Pallavi, can you elaborate more on NFE certification by auditors for verification to be conducted in hospital? I mean, how much time it will take to complete the course? Okay, to complete the course, it depends on the skill of the candidate. You don't need to participate in a training. You have to only write the examination and demonstrate your skills. The training will help you to understand, and if you don't know the subject, then only you should attend a training. The examination is maybe 4 or 5 hours. Training probably it depends on the skill of the candidate. It may be for few hours to few days to few months. It depends on the person. Normally, generally, maybe a day or two is enough, especially for FLIT program. What are the electrical safety measures taken in MRI and UPS room, which is already explained, but in UPS room, please note that for UPS, this changeover between DG and mains is creating a hazard, but there is a method already recommended in the standard. I missed the slide, probably I can share it later. Why cautery machine is in operation theater create burning effect on patient, even earthing value is okay? Actually, this is a very serious question. Cautery machine, which is supposed to, or which is used for some, removing some parts or cutting the skin or some jobs. If the temperature of or if the frequency of this device is different than what is required, instead of cutting, it will create a big hole on the skin. Instead of making a small cut, the cut becomes much bigger. Probably out of 1,000 operations, maybe 1 or 2 accidents are also happening, which is supposed to be 0. The main subject is the quality of the equipment. If you can do a pat test of the equipment, of course, this can be reduced. Number 2, the supply parameters are also affecting. Supply parameters in the sense, when you use this particular equipment, imagine there is a voltage dip, or imagine there is a voltage interruption or a change in the voltage or frequency in the supply even for a short time. Of course, then this creates a problem. Then the EMI, there are multiple problems. The solutions are already included in the standard. So we have to strictly, this is what I said, strictly comply to the standard. Don't make any non-compliance. There is a question, can there be any issue if medical staff uses UPS back to back, means supplying a UPS power to another smaller capacity UPS and then to any load? Can it be a potential fire hazard or any other issue? This is a funny situation, especially in India. Actually, if you have an UPS, what is the need for putting another small UPS for additional backup use? That means you don't relay the first UPS. So the better way is to have 2 UPS with a fast changeover. So very fast changeover systems are also available. but sometimes this is a practice in India to use it. But of course, depending upon the type of UPS, depending upon the type of isolation provided to the UPS, means there is a subject of electrical separation. So if the UPS is electrically separated, the secondary UPS is probably safe. If both the UPSs are electrically not separated, then we will be in trouble. What is the minimum qualification for NFE certified auditor and get age limit for this? There is no minimum or maximum age limit we have prescribed. There are 3 levels for FLIT. The level 1 is an engineer or a diploma holder, which is maybe 6 months experience. Level 3 is 1 year experience engineer or 2 years for the diploma holder. But please note that you have to be really skilled to pass the examination. And you also should have the required meters to carry out the test. Mr. Prabhakaran is asking, kindly make one session for residential buildings, electrical installation and testing as per the standard, and if possible, provide a checklist of for the stage wise. Of course, probably not this time. In hospital, ICU, PICU, NICU, split USC uses are viable or not? In an existing hospital, if you don't have any proper, air conditioning HVAC system, the only option is to use a split AC. But using an AC is safe, provided the electrical system is supposed to. It is capable of supporting the system. But what is more important is you do PAT test once in 6 months or once in a year. If you do a PAT test, the leakages and the problems you can identify well in advance, and if there is a problem, you can rectify so that the AC keeps working. Sir, there is sir, which hospital franchisee in India is complying with what is covered today, just to relay safely? Actually, I am also searching for this. I am also searching for a hospital so that next time when I get ill, I have to go to that particular hospital where this is complied. Sorry to make this comment. How much distance required for installation of medical isolation panel from OT areas and ICUs? Of course, it's less than 25 meters because the capacitive leakage current is the subject. So, is there any chance to have fire from HVAC in OT? In comparison to the split air conditioners, the chance is less, I would say. The chance of fire is more in places where you have air conditioners directly. So now, still we have so many comments in the chat box. So probably if any of the speakers or if any of the participants wanted to speak, probably you can raise the hand and we can allow to speak for a while.
Yeah, as Mr. Gopkumar was saying, there's a lot of information available on our website. It is accessible for our members, so you can access our old webinars and also the guide for Safe Hospital that is also available. And we are having our certification course, like many of the consultants wanted to enhance their knowledge by attending. You're most welcome. Please write to us. We have been in the chat box. We are marking the mail ID. We'll be able to assist you. And those who want to speak, you can raise your hand. I can allow you to talk. So if you have any questions specifically related to today's subject, you may please raise your hand. I can allow you to speak. Okay.
Yeah. So I think there is no question. Probably we can stop for the minutes almost now.
Patel is asking, Asmuk, you can speak. If you're hearing me out, you can unmute and speak. Okay, sir. I think we are end of the session, and we can discuss a couple of more topics when you're free, sir. We are traveling. Okay, Patel, you wanted to talk? Please go ahead. Hasmukh,
Just
please.
personally, I'm just sharing the website of NFE so that you can also look into the documents which we said. That the website address is nfes.org. As you can see, oh, sorry, where is it? So this is the website. If you go to certification, you can see FLIT. This is the fault group impedance testing professional. ESPCS. This is the electrical safety professional certification scheme. If you go into this, then you will be able to see. Scroll down. You are able to see, what kind of documents are required, who can apply. All these informations are there in our website. You can also look into FLIT. The qualification requirements, if you scroll down, these are very much there in our website. Then you can also apply. You can become member. You can renew the membership. All are there in our website. So we request you, please make use of it so that it's easy for future communication. So over to you, Mr. W.
Hasmukh, you want to talk? Please go ahead. Patel, are you there? You want to speak? Okay,
Hello.
I'm going to remove
Hello.
permission to
Am I
speak.
audible?
Yeah. Please go ahead, Jagler.
Yes. Good afternoon, sir. I want to know your thoughts about the arc fault detection device. Whether we should use it or in particularly in medical locations or in general every electrical equipment in addition to ELCB
No.
and
In medical locations, no.
okay.
I'll just show you where to use arc fault protection device. This is very specific. You are supposed to use it in the final circuits of locations where people, example bedrooms, especially for old people or young children. So AFDD is not a solution for every fire problem. Look into IS 732. This is very specifically written. You must use it only in certain locations where the risk of fire is much more. It is not like for the group in a hospital. I would recommend in a hospital. I think it is very clearly written, not for medical location, not for hospitals, because your electrical wiring itself has to be carried out in such a way that there is no arc in the installation.
Okay. So, but it provides the precaution for loose connections or any after installation damage to the cables. So if in case of the broken cable, the the sparking will be present, and due to that presence of sparking, the neither the MCB will or overload protection will able to identify it, or neither the earth fault will able to identify it because it is inside the PVC conduit. So isn't
That
it
is
a
why That is why the tests which is mentioned before you start using the electrical installation, the first test is continuity resistance test of the final circuits and all protective conductors, including protective earthing and protective bonding conductors, and the resistance of all these wires has to be less than certain limit. The limit is nothing but the length of the conductor multiplied by its resistance. There is a table in the standard. Now imagine in a new installation, you are making this testing properly. The idea is inside the conduit, there is no loose contact and there is no insulation breakdown, because insulation resistance test is the second test. If you make these two tests, you can be sure that the chance of loose contact and insulation breakdown you are completely avoided. Then the test number 6, the fault loop impedance or the automatic efficiency of automatic disconnection. This ensures that in case of any abnormal condition like overload or overcurrent, the protective devices are able to trip. Now, if you put AFDD, please seriously look into the technical parameters of AFDD. If you put an AFDD in a circuit which is taking a current of, let's say, 0.5 amperes, AFDD will not work. AFDD requires some minimum current to operate. I think it is about 2.5 amps or something like that. If the circuit current is lesser than that, so the situation is different. Number two, what AFDD does is, in case of any arcing, it disconnects the supply. So continuity of supply is lost. Imagine due to an arcing, the power supply to operation theater is lost. The patient will be in a different situation. The patient will be in danger. This is the reason AFDD and the RCDs are not allowed in group 2 location, especially for life-saving equipment. So AFDD, we have made this in our, if you look into the YouTube channel of NFE, there is a webinar made by Krish where each and every parameters of AFDD is explained. Where to use it, how to use it are very well explained. Thank you very much.
Sairam, if you are there, you can unmute and speak, or we'll end this session. Yeah, please go ahead, sir.
Hello. Yeah. Hello, sir. Am I audible?
Yeah. Go.
Yeah, sir. First of all, thank you very much for sharing the valuable information, sir. The session was very informative. Thank you very much again. Sir, my question is for Group 2 medical IT system is recommended, whereas when it comes to Group 0 and Group 1, is a TT system allowed?
Most of the biomedical equipment are not suitable to operate in TT system. So
Okay,
a TMS is preferred.
Yeah, even in the disconnection.
If you are using a TT system, in the other locations, if you are using a TT system, you have to definitely, for fault protection, you have to put an RCCB. Now,
okay.
If you are putting a 30 milliampere RCCB for fault protection, a group of electrical equipment or group of biomedical equipment together, example, let's say the LED lights, computers, all these things together produces a leakage current more than 9 milliampere or 10 milliampere, which will create nuisance tripping to the RCCB.
Okay.
Because there is inherent leakage current for the equipment, which is not a fault. Due to inherent leakage current added together, the device start tripping, which will be another hazard. So all these things need to be taken into account.
Okay, sir, if there is a possibility of altering the system from TT to TNS, depending on the space and all, what is your advice, sir? You'll recommend to change the system?
You see, in most of the installations, if you have a DG, your own DG or your own transformer, then TNS is the best. Because if you have your own DG and if you try to make, depending upon the distance between the main panel and the DG, most of them are close by. You cannot really make it.
Yes.
Yeah. To make a TT, the electrodes of the source and the distribution should be electrically separate, means 10-15 meters away. Practically, this may not be possible.
Okay, sir. And even in the disconnection times, which is there in the presentation also, TT is not shown, sir. Only IT and TN is shown. So
correct.
That is why I had a doubt, sir.
Because more and more, TNS for a normal location, IT for medical IT.
Okay, sir. Thank you very much. Yeah.
Thank you.
Yeah. Thank you, sir.
Hello, I'm audible.
Yes.
Sir, it's a very nice presentation, elaborate one. It's needed for this hour. We are going to have a very hot summer. So there should not be any fire in not only hospital locations, in multi-story buildings and other places. By the way, I would like to say only two things. That is, number one is, one person asked about the addition and alteration after handing over the building. So I want to stress a specific regulation. Wherever you put addition or alteration to an existing, whether it is handed over or not, after handing over, there will be a continuous addition of equipments by the owner management. So you require it to be under Regulation 45.5. So Regulation 45 insists whenever you put additional equipment, you test it. Specifically, Regulation 45.5 says every circuit should be tested. So it is a installation requirement as per regulation as well as Suggest 732 by a continuity of conductor and other tests. So every circuit requires test that can be done during the initial direction only. So it's mandatory as well as standards compliance. Another thing, there are people asking about AT system. Actually, TNS is mandatory for, as per NEC, it's mandatory for hospital locations. Also, there are, I can say that the term TT itself has to be reviewed by the EC committee. There is no TT system. Invariably, all the TT system will be ending up with a poor TNS system or an inefficient TT system because of what do you call that? The earth current depends upon the seasonal variation. Also, there are earth mass. There are invisible conductors between the source and the consumer side. That can be a rail or the municipal pipeline, or even so many things are happening. There are also zero sequence impedance between the conductor and the earth mass. So there is no TT system. So if we test a installation which is supposed to be a TT system, we cannot find as per calculation it's a TT system because of such additional factors. Only TNS is the solution. And another person asked how to convert. Converting a TT to TNS is just a very minimum price. Suppose the transformer, the MET, can be at the main panel. You just provide a bar, a copper or steel bar that can connect the source, neutral source, earth mat and your LV installation. So these are all the things very cheap, and we can have a confident installation. By testing fleet fault impedance test, you can have this is the value. In TT, you can't have any fixed value. So we have to assume things and do it. Okay, you require ELCB or RCD. So many things are coming into picture. They are not conclusive, I can say. Only where the system fails fault loop impedance because of lengthy and final circuits, you can have RCD. As far as hospital is concerned, supply continuity is more important. That's why installation monitoring device with IT system, IT transformer is provided in the hospital. As GK observed, IT, people that IT is everything is IT. IT transformer itself is a very specific thing. I think it's not, we are not having any manufacturing capability in our country to have a IT transformer, maybe of 10 kV or 20 kVA. It's very tough. We are importing only. So these are all my observations. With that, we would like to have the participant to be conversant with the NEC, where the special provision is there for hospital locations. With that, I could like to conclude. I congratulate Mr. Appreciate PK and Dominic for their efforts. Thank you, sir.
Thank you, sir. Thank you, sir. As you rightly said, a true TT doesn't exist because of these unreliable connections through the armoring, through the cable glands and all. So instead of making an unreliable situation, make a proper TNS. Thanks for that point, sir. Thank you. So over to you, Mr. Dominic.
Lot of questions on certification program that we have been conducting. I request everyone to simply go to our website, www.nfees. You can see on my background, there is our logo and Mr. Gopaman logo, there is a website. And also we are giving in the chat box, and also email ID of our president is also given, our secretary email ID is given. We are going to run a very serious certification program to the need of the country. NFE is the only association in the country. As I said, we are the fastest growing society when it comes to electrical safety. And the number of training programs that we have been conducting and number of awareness programs that we are doing. In the beginning, I supposed to do that introduction of NFE, but unfortunately, sometimes we were overconfident that system will work, but we had glitches. And we have conducted over 59 workshops. So next conference is happening is in Bangalore on 17th of April. Those who are from Bangalore, especially from the hospital segment, please register. We'll be sending out the invite to all those people register. We had a record registration of 1,215, today, which shows that interest that our professionals are keen to learn. That's one of the record, maybe the fifth highest registration that happened, and good turnout, and people are hungry to learn and share the knowledge. So I would welcome you to join NFE. 3,000 member out of 30 lakh in electrical safety is nothing. Not even 0.1% we have members when you look at the population of electrical engineers in the country. So we need more and more. We should support be read as 30,000 member. So I'm sure that we are marching towards that. Please do join, help us, support us. You have seen Mr. Gopakumar in most of the thing. We need more speakers to come on the subject matter experts. We need more speakers to come forward. It's a wonderful platform for all of you, all our professional safety and electrical. You will see the value for 1,000 rupees that you pay every year. So we are also running school programs. Those are intended to set up a school college chapter, student chapter in a college. Also, most welcome. We want to establish a student chapter in every colleges. So we are looking at 5 colleges in every state for this year, and we want to cover schools as 50,000 children that we need to cover. We require CSR funding for it. If you have any company known to you that they have CSR fund, we love to exchange emails and so to give them a supporting document. With this, thank you for wonderful, registration we had, wonderful gathering we had, very important topic that we covered. We hope that there won't be any more fire accident, especially in ICU and OT, where we cannot be, in other ways we can run and escape, but these are the people who are immobilized and they are unable to, they are wired around the body. They cannot, it's not that easy to evacuate those people. So we only pray and hope that there won't be any more such accidents in the country. Thank you so much. Thank you to our President, Mr. Gopakumar, for sparing his time and sharing knowledge. And also thank our Apau sir, the General Secretary of Focus, and very learned engineer, who is also retired Chief Electrical Inspector of Tamil Nadu. And he's serving the country after retirement by sharing his wonderful knowledge that he has. So thank you, Lakshmi, for back-end support, and thank you entire team who have been working hard to make this event successful. Look forward to see you for our conference in Bangalore, 17th of April. Thank you so much. Thank you so much. God bless you all. Have a wonderful weekend.